Continuing with the topic of yesterday, that the first attempt to classify the elements was done by Daubernier, but we have already discussed about his limitations also, that all the elements known at that time he was not able to classify them. He was able to find only three triads. Okay, then the second attempt to classify the elements was done by Newland. John's Newland, he was a chemist from English. He was an English scientist who has done the second attempt to classify the elements. Now, what was the principle, or what was the criteria on the basis of which he tried to classify? Again, he gave us the law of octaves. And what is the law of octaves? Let me describe it in front of you, that what a law of octaves suggests. But his criteria of arranging the element was also, first criteria was increasing atomic mass. He also said that if we have to arrange the elements, we have to arrange it in such a manner that their mass should be increasing atomic mass. So the first criteria used by Newland was increasing atomic mass. This was the criteria that was also used by Daubernier. But along with this, he gave us one more criteria which he called as law of octaves. Law of octaves. First criteria was to see to it that the elements have to be arranged in order of increasing atomic mass, and second criteria was law of octaves. Now, what is law of octaves? Actually, the law says that when elements are arranged in the horizontal rows in order of their increasing relative atomic mass, the property of every eighth element is similar to the first one, right? Like he said that if we try to arrange the elements in order, in increasing atomic mass order, but in the horizontal rows from 1 to 8, every eighth element show the repetitive property of the first one, like what we see in case of musical notes. Like if I try to find out that what all are the musical notations which are used in music, they are sa, re, ga, ma, pa, da, ni, and sa. Once again, right? Like here we are having how many? We are having 1, 1, 2, 3, 4, 5, 6, 7, and 8th is the repetition of the first one. He also said that all the elements must be grouped in increasing atomic mass in the horizontal manner, so that every eighth element will show the repetitive property of the first one. This is what the law of octaves suggests, that when elements are arranged in horizontal rows in order of increasing atomic mass, the properties of every eighth element will be the repetitive property of the first one, or will be the repetitive property, repeating property of the first one will be similar to that of the first one, right? So he also arranged, you can see on your screen He prepared a table like this in which he arranged all the elements in increasing atomic mass, like he arranged hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, and then fluorine. Fluorine, chlorine, cobalt, nickel. They all were showing the repetitive property of the first one, right? This is what he suggests. Okay, he tried to arrange. Somehow he tried to form the tabular manner, all the elements, but there were limitations also. Now, what was the limitation? One by one, we will be discussing about those limitations. He said that this is the one of the biggest limitation. He said, and this is one of the biggest cause of the failure of Newland law of Otis. You know what he said? When Newland was there, only 56 elements were known at that time. At the time when Newland tried to classify the elements in the form of octaves, so how many elements? There were only 56 elements which were known at that time. Okay, then it's okay. But what Newland said, he said that no new element will be discovered in future. This was one of the biggest drawbacks of Newland law of Otis, because he closed the chapter for research, and in science there is no closure for research. You can still the research is going on. We cannot say today we are having 118 elements, and today we cannot say that no more further element will be discovered. It was the biggest drawback of Newland's classification, that he said only 56 elements will be known and no new element will be would be discovered in future. Right? This was one of the limitation. Second limitation was that he was not able to classify all the elements known at that time. Right? As per his classification, as per the law which he provided to us, he was able to classify only 20 to 25 elements out of 56 elements. So all the elements which were known at that time, he was able to arrange only the lighter elements, that is those who were having the atomic mass up to 40. The rest of the element he was not able to classify. So this is the another drawback of Newland. So first limitation is that he said that no more further element will be discovered in future. Only 56 elements will be known. Second limitation is that he was not able to classify all the elements. His rule was applicable only to those atoms whose atomic mass was less than 40, and those whose atomic mass was more than 40. Those elements where he was not able to arrange them in this table, in the table which was being prepared by Newland. Third was that wrong order. He placed two elements at the same time, but if they are having distinctive atomic mass, how is it possible that you can give that? You can give same place to two atoms? Like you can see in the table, cobalt and nickel. Cobalt and nickel was placed in the same group, and even at that time what he has not considered was atomic mass also, because one of the criteria to classify was increasing atomic mass. If we try to find out, the atomic mass of cobalt is more than nickel. Atomic mass of cobalt is more than nickel. So he should have placed nickel first, then cobalt. But he has done it wrongly, and he was not able to give the answer to this question also, that why there is the wrong order of the elements. Although one of the criteria to classify the element is increasing atomic mass, but he has compromised this uh, observation while giving the place to some of the elements like cobalt and nickel and selenium and lanthanum. Okay, so Newland not only placed two elements. One of the drawback was that he placed this two elements, although their atomic mass was different, so they should have been placed in different rows, but he placed them in the same row. But although he placed them in the same row, but let me tell you one thing, that he placed them in the wrong order of atomic mass. That is, he placed cobalt first, where nickel later on. Whereas it is that he should have placed nickel first, cobalt later on. And he was not able to explain also this, right? So this was the biggest, these were the limitations of Newland's law of octaves. One limitation was he was not able to give the first limitation was that he said that only 56 elements will be known. Second limitation was the law of octaves was not applicable to all the elements known at that time. He was not able to classify all the elements known at that time. Third was that he compromised on the first observation, that is increasing atomic mass. He placed atoms in the wrong order of increasing atomic mass. Even he placed the two elements in the same column. He placed the two elements in the same column, and noble gases could not be incorporated in his periodic table. नोबल गैसेस को कोई जगह नहीं मिलेगी उसके पीरियोडिक टेबल में, राइट? सो दीज वर द ऑल लिमिटेशन ऑफ द न्यूलैंड. Okay, so now I hope that so we are now going to discuss about the Mendeleev's periodic table. The first real breakthrough which was provided was being provided by Mendeleev. If we say that is in this reality, the first that is the first thing which was being provided, the real way in which the elements was classified was done by Mendeleev. The first breakthrough in the classification to categorize all the elements known was done by Mendeleev. But before we discuss that, what all was the principle or what all was the criteria which was set by the Mendeleev so that they can classify the elements known at that time, somehow he prepared a proper table in which he tried to arrange all the elements known at that time. So the characteristic features, first of all, we are going to discuss about the Mendelevian periodic table, which is there on your screen. The first characteristic of the Mendelevian periodic table is that Mendelevian periodic table consists of the 7 horizontal columns. Horizontal columns, that is these columns. There were the 7 horizontal columns, and these columns he called as periods. The horizontal columns, there were 7 horizontal columns, and he called these columns as periods, right? Along with it, there were the vertical rows also, and these vertical columns or vertical rows, he called them as the group. So this was the characteristic feature of Mendelevian periodic table, that is there were the 7 horizontal column which he named as 1, 2, 3, 4, 5, 6 and 7, what you can see on your screen, and there were the horizontal vertical columns which he called as groups, which he named as 1, 2, 3, 4, 5, 6, 7. Okay, and there were the 7 periods, the horizontal. Okay, this was the characteristic feature of the Mendelevium periodic table. Now, what was the criteria that was used by Mendeleev to classify the element? First criteria was the same, that is increasing atomic mass. He also said that all the elements which are to be arranged in this chart, we need to place them in order of increasing atomic mass, right? Now, second criteria which was set by Mendeleev was a revolutionary one. He tried to prepare the oxides and hydrides of all the elements known at that time. A periodic table can be defined as per Mendelevian periodic law. He said that a periodic table may be defined as arrangement or a chart which classifies all the elements known on the basis of their properties in such a way that element with similar property are placed in the same vertical column, and dissimilar elements are separated from each other. All right. He also said that when all elements are arranged in order of their increasing atomic mass, elements with similar properties are repeated after a certain period, after a certain interval. What he laid importance was that elements with similar chemical properties must be placed in the same column, vertical column, which he called as group. Elements with the similar chemical property must be arranged in the same group, while with those elements with the dissimilar property must be arranged in the separate one. Now, in order to study their chemical behavior, chemical property, so what he tried to prepare was the oxides and hydride, right? In order to study the chemical property, he prepared the oxides and hydrides. That is, he was the one for example, he prepared the oxide, and then for a particular element, he just find it out that what will be the formula if the element will react with oxygen, and then same element, what will be the formula if the element will react with the hydrogen. Then in this manner, he tried to put all the elements who are having the same who are having the same formula, he put them in the same, right? Mendeleev classified elements in order of increasing order of their atomic mass. He prepared their formulas by reacting the element, not by let me tell you, he prepared their oxide, like he prepared the oxide of carbon, he prepared the oxide of aluminum, he prepared the oxide of hydrogen, he prepared the oxide of all the elements known at that time, right? And those who were having the similar formula, he put them in the same group. Like he prepared the formula of sodium with oxygen. For example, this is just an example. Sodium and oxygen. We know the sodium, as per in 9th class, you have just studied how to find their formulas. We have to write down here, we have to write down symbol. Here we have to write down the valency. You know the valency of Sodium is 1 and the valency of oxygen is 2. Now, in order to find out their molecular formula, so what will be the molecular formula? It will be Na2O. In the same manner, he prepared the formula of each and every element known at that time, with whom he prepared the formula with oxygen and hydrogen, right? And then who were having all same formula, he put them in the same group. Like, let me tell it to you like this. If I place it horizontally so that I can get the maximum space. Now the board will be more visible to you. So he prepared their oxides and hydrides and tried to arrange the element in this manner. Although I may not be able to show you all, I will try my best. Groups were the vertical ones and periods were the horizontal ones. So he named them as 1, 2, 3, 4th group, 5th and 6th and 7th. Okay. Then what does he prepare? He prepared their oxides and hydride for all the elements to generalize the name of the element. He took them as R. In first column, he put those elements whose formula was similar to that of R2O. R2O, where R can be considered as any element like Na2O, this will be placed in the same column. Then K2O, okay. Then Li2O, lithium oxide, because they are once they react with the oxygen, they will form the similar formula. Now, just to generalize, he said it is R2O, and those who are having whose formula resemble to R2O, he put them in the same group. Okay. Then with hydride, they should form RH. With hydride, they should form RH. Right. In second group, he placed those elements whose formula was RO and hydride was RH2. In third group, he placed those whose formula was similar to that of R2O3 and RH3. In fourth, he arranged RO2 and RH4 and so. Now, what was this? He wanted to study their chemical property so that all the elements, because those who are having the same formula, their chemical properties will also be same. So then to generalize all the elements in the group, he used the word. This is the way how he tried to study their chemical property, and on the basis of his observation, he said that all the elements while arranging them in a chart must be classified in such a manner that they are arranged in increasing atomic masses, and the properties of the elements with similar properties are placed in the same vertical column, and dissimilar are separated from the other ones. So in the Mendelevium periodic table has 6 horizontal rows which he call as periods and 8 vertical rows which is called as groups. The group 1 to 7 has 2 subgroups A and B. Okay, so this was all about the Mendelevium periodic table, how he tried to categorize, how he tried to arrange all the elements with the similar chemical property in the same column which he called as groups, right?